Trig. We are going to be jumping into lesson 47. If you were here, I would give you a printout and we would go through these graphs together. But if not, you'll have to kind of follow along. So 47.A, we're going to keep working on the graphs of sinusoids. And the Trig book is really slow. It does one transformation at a time. So in 47.A, we're looking at vertical sinusoid translations. Remember, a sinusoid can be both cosine and sine. So vertical translations, you've seen them before when it comes to quadratic, but vertical translations, a vertical shift shifts our graph up or down. Now, in a sinusoid, remember, it's both, a sinusoid is both cosine and sine. And I've written the basically the format of our sine equations. So notice that instead of, when we learned other transformations, the vertical shift is after. But for a sinusoid, the vertical shift is going to be listed first. So plus or minus k is your vertical shift. And remember, A is our amplitude. Remember, that is the height of our valleys and our peaks in our graph. So the capital A is your amplitude. Your vertical shift should be listed first, though, when we write these equations. Now, remember, if theta, that means our graph is in degrees. And we use x when our graph is in radians. Okay? So we're going to do some examples together. And I wish I had another. We're going to do one at a time to kind of prep you for what you'll see in your homework. So here is part A. Okay, I noticed that my amplitude, right, my amplitude, well, sorry, I shouldn't do amplitude. I should have mentioned that my vertical shift is also my center line. So K is the vertical shift, but K is also the center line. In a parabola, our vertical shift is where the vertex is, but in a sinusoid, it is where our center line is. So I notice that my center line is at 3, and it happens to be at positive 3. So I know that K equals 3. I notice my amplitude, so that is the distance from the center line to the bottom. So from here to here is, if that's at 3, then that is at 1. And from the middle to the top is at 1, right? If this is at 3, then my amplitude, or A, is 1. I also know that it's in degrees, so I'm going to use theta. So here's how I'll write our equation. Oh, and I should also pay attention to whether this is sine or cosine. Now, if you look at this graph, notice that it starts like at 0, like the peak isn't on your y-axis, but the bottom of a mountain is, so I know that this is sine. So I know that my vertical shift is 3, K goes first according to this form, so 3 plus 1 times the sine of theta, right? It's theta because it's in degrees, so I'm going to rewrite that because I don't need the 1, so 3 plus the sine of theta. So that is the equation for this graph. So let's try the next one. I'm sorry, let me grab another piece of paper because I'm trying to do these one at a time. All right, so now let's look at this. Now I'm going to assume that this is a sine as well because of the location of this. Okay, we have it's about to, why am I forgetting the terminology? If it's not a peak on the y-axis, then I can assume it's a sine. So first I'm going to talk about my center line. Notice it's at -10. So my center line is at -10. So that is the value of k. My amplitude goes from -2 to -14. So I know my amplitude is 4. Because -10, the distance between -10 and -14 is 4. And the distance from -10 to -6 is also 4. So I know my amplitude is A. But I know that a typical sine function, the sine function should be the nearest, here would be sine, a regular sine of theta, should start at 0, 0. Because the value of 0 is 0 for sine. Okay, so I know this is sine because of the location of that, but notice my graph has been flipped over. So I notice that there has been a reflection. Now that's from a prior section. So here should be our formula. Y equals k goes first. Now this negative right here is because of the reflection. And then I'm going to write my amplitude and then the sine of theta because it's in degrees. So this would be my answer. Next one, and I'm going to skip over to D, and we'll go back to C. Now I notice the location of this peak is on my y-axis, so I know this is cosine. I notice that these are in radians, so I know I'm going to use x. Okay, now let's identify my center line and my amplitude. I know my center line is at -8, so k is -8. Now amplitude, the distance between -8, remember from the center line down or the center line up should be the same, so the distance between -8 and -5 is 3. The distance here is also 3. So I know my amplitude is 3. There is not a reflection here because the parent function of cosine, the value of the cosine of 0 degrees equals 1, which is why it's up here. But ours has been shifted up. Okay. So my formula, I'm going to put k first, -8. There's no reflection, so plus my amplitude and the cosine of x because it's in radians. So let's go back to E. Now if you look at the two of these, I know that this one is sine because I don't have a peak or valley on my y-axis. But notice in part C, I have a valley on my y-axis. So I know this is cosine. Because it's in degrees, I know it's theta, but I know that there's been a reflection because this peak should be up here. Now we can identify the other pieces. My center line is at 7, so k equals 7. And my amplitude is 2 because the distance between 5 and 7 is 2, and the distance between 7 and 9 is 2. So y equals 7, it's a positive 7 because that's where my center line is. There has been a reflection, so this next part should be negative. Then my amplitude, the distance from the center line to the bottom, which is also the same as this. And then cosine of theta because it's in degrees. So if you wanted to pause the video, try to write the equations for the next two using what we've done so far. So if I was you, I'd pause it, try to work these two out, and then we can talk about them. But I'm going to go ahead and go through so you can check your work. So I see that this is in radians, right? So I'm going to use x. I see that my center line, which is this dashed, right? The center line is at a -2, so k equals negative, oh, I'm sorry, that's a positive 2. It's sometimes hard to see, but if you need clarification, remember the amplitude from the center down and the center up should be the same number. So the distance from 10 to 2 is 8. The distance from 2 to -6 is also 8. So I know my amplitude is 8. Now, based on the fact that my on the y-axis is not a peak or a valley, it's the middle, I know that this is sine. So 2 is first. Now I notice, right, a normal sine function, this should be up here. The parent sine function should start at the origin and go up. That's the sine function. Your cosine function, the peak, this is cosine. The peak is on my y-axis. In a sine function, I should have the middle at 0, 0. Here, the middle of my peak is at 0, 1. So everything I'm looking at, I'm basing on the parent functions, what they typically look like. So I know that this is sine, but I know it's been reflected. So minus, then my amplitude, which is 8, and it's going to be the sine of x because it's in radians. So again, I would pause the video, identify is this cosine or sine based on, we always look at my y-axis, is it at the origin, and is it the middle of, is it increasing or coming down, or is there a peak on the y-axis? Then look at your center line, and then your amplitude, and has there been a reflection? So if you want to pause it, try to write it, but based on the location of this, I know it's cosine. Based on the fact that it's degrees, I know it's theta. I know that this center line is at 20, and the distance here and here is both 10, so I know my amplitude is 10. So y equals your center line. There has not been a reflection, so I'm leaving this as positive. And then my amplitude, I know this is cosine and it's theta because it's in degrees. So review, remember I have y equals, I have either a positive or a negative amplitude sine of theta. It's negative if reflection. This is review from the first lesson that I taught you on graphing. Sorry, you can't see that. And A is our amplitude. So the only thing we added today was a shift up or down. Okay, so that is 47.A. I'm now going to jump into 47.B, and I'm just going to write on the back. 47.B is on the arc tangent. So let's go over. Remember, tangent of theta is your side ratio. Arctan, you're looking for the missing angle. So the regular trig functions, I'm looking for a side ratio or a missing side, either one. It's like when you use it. But arctangent is looking for the opposite. It's looking for the angle. Okay, so also, this is review, but for arctangent to be a function, it's restricted to quadrant 1 and quadrant 4. It's the same as arcsine. So arctan is restricted to these quadrants so that it passes the vertical lines test. Okay, so it's in order to make it a function. So we're going to practice several. So what is the sine of the arctangent of 1 over root 3? Okay, so what are some things we always do? Well, we always draw reference triangles. So I've got my 30, 60, 90. The smaller angle should be 30, right? So this is short leg is 1, hypotenuse is 2, long leg is root 3. That's my 30, 60, 90. The other one is a 45, 45, 90 where my legs are the same. So 1, 1, root 2. So when I see this, root 3, I know I'm talking about the 30, 60, 90. Now I'm also going to draw a picture. So first, second, draw a picture. These are both positive, so it must be in quadrant 1. Now I know that tangent is opposite over adjacent. So that means from here, my opposite side would be 1, and my adjacent side should be root 3. Okay, based on that drawing. So theta is here. It's saying that the opposite side is 1 and the adjacent side is root 3. So what angle produces that side ratio? So that's what you're asking. What angle produces a side ratio of 1 over root 3? And in this case, if I look at this picture, the 30 degrees. So I know that this is 30 degrees. So the answer to this is 30 degrees. But because I have the sign out here, it's asking us the sine of theta. I know sine is opposite, so 1, but I need the hypotenuse. So because this is a standard 30, 60, 90, I know the hypotenuse is 2. So it would be 1/2. Okay. Number 2, what is the arc tangent of the tangent of 135 degrees? I know that looks a little crazy. So let's first talk about the tangent of 135. So I'm going to draw a picture. The tangent of 135, remember it starts here. So there's 135 degrees. But that is not the angle we use. We use the related angle that is developed from the x-axis. So 180 minus 135 means I'm actually using 45 degrees. You have to actually build a triangle to evaluate these. This angle 135, that's going to give me an obtuse triangle that I can't use. So we're using the acute angle. So I'm actually evaluating the tangent of 45 degrees. Okay, now a tangent of 45, right, is 1. This is 1. This is root 2. So I'm going to evaluate the center first. So the tangent of 135 is 1 over 1. But because I'm in quadrant 2, all students take calculus. I know I'm negative. So now I'm evaluating the arc tangent of -1. So this is asking what angle would give me the arc tangent of -1. So remember, I'm limited, arc tangent is limited to quadrant 1 and quadrant 2. So if this is a -1 over 1, then I know I'm located in quadrant 2. So I'm going to be a -45 degrees instead of a positive 45 degrees. Because if it was a positive 1, it would be in quadrant 1 because it'd be 1 over 1. Because it's negative, that means my triangle is down here. It looks like this. This would be 1 over -1, opposite over, and I know it's negative because y is negative down here. So it's a -45 degrees. I know that's a little crazy. And it's because it's restricted to positive 90 and -90 degrees. So I know it has to be a -45. So that is the answer. I know these are kind of complicated and I wish you were here, but this is where we're at. All right, what is the arc tangent of the tangent of 210? So let's draw that. So if I start here, I know that's 180, right? So, sorry, my screen timed out. Give me 2 seconds. So 210 minus 180 is 30 degrees. So I'm 30 degrees down here. So I'm actually evaluating the tangent of 30 degrees. So I need, if this is 30, this is 1, this is root 3. So arc tangent, the tangent of 30 is 1 over root 3. So 1 over root 3. So I have evaluated the center. I have replaced the tangent of 210 with the tangent of 30. Now what we have to talk about is if it's positive or negative here. All students take. So this is positive. So now this is asking what angle produces the ratio of 1 over root 3. And the answer is 30 degrees. Phew. Moving on. Well, here, let's see if I can fit this last one here. What is the arc tangent of the tangent of 120? All right, so again, the tangent of 120 would be here. And 180 minus 120 means that this angle here is 60 degrees. So I've got 1, root 3, 2, because that is my 30, 60, 90. So arc tangent of, this is really of tangent of 60 degrees. And the tangent of 60 degrees is root 3 over 1. Now all students, it's asking me the negative angle. So this is asking what angle would produce this negative relationship, and so it would be negative 60 because remember I'm limited, so it's either positive angles here or negative angles here for arctan. And it's either positive up to 90 or down to negative 90. So it has to be negative 60 degrees that would produce that ratio. I know that's kind of crazy. I'm going to write on the front what you get to skip for your homework. If you're watching this video, right? I don't know if you are. Homework, skip number 2 through 4, 6. And let me confirm with my homework page. Yeah, 12, 14, 20, and 22. Which is awesome, right? I skipped the even. And that completes that section.